Anytime we measure an attribute of people during an experiment, we expect the results of those measurements to vary. For example, the scores for every person in the study will not all be the same. This is clearly a statement of the obvious. But how do we statistically explain why this happens? Well, scores vary due to both random and systematic influences on each individual during the measurement process. The effect that these influences have is not the same for each person measured, and so their scores will vary. These influences can be grouped into three general categories. 1. Interindividual differences. People naturally differ in the amounts of the attributes being measured even when they are all treated alike. For instance, if we measure reaction time of a group of individuals, some people will naturally react faster than others. Older people will often have slower reaction times than younger people. These differences will cause the scores of people being measured to vary. These variations are considered systematic variations because each time you measure the same person, the effect of these interindividual differences will be approximately, but not exactly, the same. People systematically differ in all manner of characteristics that we may be interested in measuring: height, weight, IQ, preferences, attitudes, etc. These differences, while systematic within individuals, will vary randomly within a population of many people. So, while these systematic characteristics will raise or lower an individual's score in a systematic manner, across many people these differences will average out if a sufficiently large random sample is taken from a population. Therefore, the long-run expectation of the effect they will have within a very large group will be zero. That's why random selection of participants and random assignment to conditions in an experiment is so important. 2. Intra-individual differences. The variation in scores on a measurement will be affected by transitory things that are unique to a particular individual at the time of the measurement that can cause their scores to vary. Things like the amount of sleep a person had the night before, how the person is generally feeling, as well as anything else that may be related to how a person responds to a measurement comes under the heading of intra-individual differences. These effects are not considered to be systematic because they will vary in their influence on an individual each time a measurement is made. These are random sources of error because they are not predictable. These intra-individual influences will also vary randomly across all individuals in a study, assuming random selection and assignment, so the effects will cancel each other out in the long run. 3. Lack of experimental standardization. There will always be variations in the experimental setting that can unintentionally cause scores to vary. Perhaps the room in which the experiment is being conducted is hotter on some days than others. This might affect people's responses. Data may be collected at different times, on different days, in different places, or even in different seasons. These types of variations in the experimental setting can have unpredictable effects on people's responses to the measurement process. These influences could be either random or systematic. It is all these influences that cause individual scores to differ. If these influences did not exist, obviously an impossibility in the real world, everyone's score in the sample would be exactly the same, and there would be no variation in them at all. If this were the case, we would always be able to be 100% confident in the results of any study we conducted, and we would not need inferential statistics. We could just look at the sample means of the different groups in a study and tell if our treatment worked. Taken together, we call these influences on a person's score error. Because the amount of error in each individual's score will be different, these error scores will vary. We can quantify the amount that the scores vary in the usual way by calculating the variance. Because this variance is really due to the variance of errors, we can properly call this error variance. In fact, we can say that variance in scores is actually the same thing as the variance of errors. It is important to understand that the term error is not meant to imply that some mistake has been made in a study. From a statistical perspective, error is simply all the unpredictable influences that cause individual scores to vary. The errors that cause individual scores to vary are unique to each individual. If you knew the amount of error present in one individual's score, you would not be able to predict the amount of error in any other individual's score. In statistical terms, we say that these error scores are independent. Another way of saying the same thing is that these errors are uncorrelated. As you will learn, independence of error is the most important assumption that must be met when running an ANOVA. If this assumption is violated, the results of your ANOVA would no longer be a reliable measure of the differences between the means that are being tested. We will have more to say about all the assumptions in ANOVA in a later video. If we were able to look at all the error scores from individuals in our population, they would form a distribution of errors. Like any distribution, you can calculate its mean. Because these errors are considered to be a random phenomenon, their long-run mean will always be 0. And, as we said, you can also calculate the variance of this distribution. The variance of this distribution of errors is referred to, for obvious reasons, as the error variance. It is simply how much the errors of measurement vary around their mean of 0. The larger the error variance, the more the errors will vary, and therefore the more the scores will vary around their mean. This is because it is these errors which are responsible for the variation in scores within the study. In the impossible case where there were no errors, everyone's score would be exactly the same and would be equal to the mean of the group in which the individual was a member. We will be able to show you exactly why this is the case when we demonstrate via simulation how we can break scores down into 3 individual components that, when combined, will result in the actual score we observe for each person. This concludes our video on experimental error. We will have some more to say about the topic of error in our next video as well. In that video, we will be discussing the underlying mathematical model of individual scores in the context of a one-way between subjects analysis of variance. We hope that this video contributed to your understanding of the role that error plays in the variation of scores when conducting studies. Thank you for watching.